So this is a topic called manipulation of formula. So we're taking a formula or an equation, let's say, and we're manipulating or rearranging it to get a single letter by itself. So if we look at the first one here, we have that 4D is equal to 2C over 3 plus A over 5. Now we want to try and get the A on its own. Now there's a number of ways we can do these. In general, if there's fractions in a question, it's a good idea to get rid of the fractions first. So I'm going to put 4D over 1 and I'm going to make a common denominator. The common denominator of 1, 3 and 5, which is 15. I then say that 1 into 15 goes 15 times. I multiply that by the number on top, 4D, equals 3 into 15 goes 5. Multiply that by the number on top, the term on top, 2C, plus 5 into 15 goes 3 times, and we're going to multiply that by A. If there's an equals on top, we can get rid of the fraction, and we're going to multiply out the rest, so we have 60D equals 10C plus 3A. I'm trying to isolate the A, so what I'm going to do is I'm going to remove a 10C from the right hand side. I can do that by subtracting 10C from both sides. And then finally, to get A on its own, I'm going to divide both sides by 3. So I have A is equal to 60D minus 10C over 3. And so I've written A in terms of C and D. So the objective is to get a letter by itself. Like, just to explore how that might have been done a different way without necessarily getting a common denominator straight away. Well, if we take this equation again, 4D, and it's equal to 2C over 3 plus A over 5. If we keep the A over 5 on the right hand side and we subtract a 2C over 3 from both sides, we have this. And now if I multiply the left hand side by 5 and the right hand side by 5, it will get rid of the 5 from the bottom of the right hand side. So I'm going to multiply the left hand side by 5. 5 on 4D minus 2C over 3 equals 5 times A over 5 is just A. And we have written A in terms of D and C. Could we do more with it? Well, we could multiply it out. 5 by 4D is 20D minus 2C over 3 equals A. Doesn't look exactly what we had, like what we had over on the left hand side here, but we could find a common denominator with the terms on the left. Put that over 1. 1 into 3 goes 3. 3 by 20D is 60D. 3 into 3 goes 1 by 2C is 2C. And so you could get to the same answer another way, but the best thing I think to do in these is to get rid of the fractions first. Okay, let's have a look at the second one. So in the second one we have C equals the root of y minus x, and what we're trying to do is we're trying to get x on its own. So I'm going to square both sides. So if I square the left, I have c squared, and then I'm going to square this square root. And if we square a square root, we get what's underneath the square root. So they basically cancel each other. We get y minus x. Now I'm trying to get x on its own. Now if I bring the y over the other side, I mean, I definitely can do that, subtract y from both sides. But then what I have is I have a minus x. What would I do then? Well, I don't want to have a minus x. I need to get x completely on its own. So I would divide both sides by minus 1. And if I divide the left hand side by minus 1, I get minus c squared plus y equals x. Or basically we're just changing all the signs. So x is equal to y minus c squared. Now, would I have actually done that? No. If I was doing these, I like to bring the term that I'm looking for, the letter that I'm looking for, to the side where it's positive. So I have a minus x on the right, so I'm going to add an x to both sides. So that gets rid of it from the right hand side and we get it on the left hand side. And then I'm going to subtract a c squared and add a y to both sides. So I have y minus c squared. So obviously the informal language is bringing minus x over here and making it a plus x, and bringing minus y over and making it a plus y, and plus c squared over and making it minus c. So either way, whatever way you break it down, we've isolated x. X is equal to y minus c squared. Okay, the last one we're trying to get c on its own. So we have, let's see, 3d equals b on c plus a. I'm trying to get c on its own, so it's inside a bracket. I need to multiply out the brackets first anyway. So b by c is bc and b by a is ab or ba. Let's write it in alphabetical order. I'm trying to get the c by itself, so I'm going to subtract an ab from both sides. So 3d minus ab is equal to bc. And then I'm trying to get c on its own, so I'm going to divide both sides by whatever is beside the c, a b, and I get 3d minus ab over b is equal to c. And so I've got c on its own, and that was the objective. I'm going to throw in another one here. So just what would happen if the letter you're trying to isolate appears twice. So something really simple. I'm just going to put up, if we had 4b minus 7a equals, let's say 2 on b plus c. And what I'm trying to isolate here is the b. Let's say it says write b in terms of a and c. Well, step one is get rid of fractions, or if there's any brackets, let's multiply them out. So 4b minus 7a is equal to 2b plus 2c. I'm just going to put the b in a square bracket over here so that we can remember what we're trying to get on its own. Now there's two b's here. How do I get them on their own? Well, I can bring them to the left hand side. So I have 4b minus 2b equals 2c plus 7a. I have 2b is equal to 2c plus 7a, and then divide both sides by 2, and I get b is 2c plus 7a over 2, and b is on its own. Now let's do one further example. Let's take this idea and let's replace the 2 with, let's say, an x. And what I want to do is I want to get b on its own. The process is similar, so let's get rid of all this, and the only difference in the second line is that when you multiply x by b, you don't get 2b, you get xb. We want the b's on the left hand side, so 4b minus xb equals 7a plus 2c. But the problem here is, unlike the last time where I had 4b minus 2b, which was 2b, I can't subtract xb from 4b. X isn't a number. So what I have to do is to isolate the b, remember that's what I'm trying to do, isolate the b, I need to factorize it. So I take a b out of the first two terms, or factor it out, I get 4 minus x equals 7a plus 2c. The 4 minus x is being multiplied by the b, so to split that I need to divide both sides by 4 minus x. Divide the left by 4 minus x, you're left with b, and then divide the right by 4 minus x, and we get 7a plus 2c over 4 minus x. And we've expressed b in terms of a, c, and x. Okay, so 4 little examples there. 5 if you include this second type of, let's say, including a factorizing aspect to get the letter on its own. And not as popular in recent years. When they've come up, they've kind of come up in a couple of real-world type questions where you've been given a formula for a real-world scenario and you've been asked to get a different letter by itself. But that's the theory behind it.